Q9119. Which flight conditions of a large jet airplane create the most severe flight hazard by generating wingtip vortices of the greatest strength? A. Heavy, slow, gear and flaps up. B. Heavy, slow, gear and flaps down, comma. C. Heavy, fast, gear and flaps down. The correct answer is A. The strongest vortices are created by heavy, clean, flaps up, and sluggish general aviation aircraft. 9120. Hazardous vortex turbulence that might be encountered behind large aircraft is created only when that aircraft is A. Developing lift. B. Operating at high air speeds. C. Using high power settings. The correct answer is A. Hazardous vortex turbulence that might be encountered behind large aircraft is created only when that aircraft is developing lift. Wingtip vortices, which are the main source of the hazardous turbulence, are formed as a result of the pressure differential between the upper and lower surfaces of the wings during the generation of lift. As an aircraft generates lift, the air flows over the wings and creates a swirling motion at the wingtips, forming wingtip vortices. These vortices are more pronounced when the aircraft is producing a significant amount of lift, such as during takeoff and landing phases. The other options, operating at high air speeds, B, and using high power settings, C, can affect the intensity and behavior of the vortices, but they are not the sole factors responsible for their creation. The development of lift is the primary factor in the formation of wingtip vortices and the subsequent hazardous vortex turbulence. 9121. Wingtip vortices created by large aircraft tend to A. Sink below the aircraft generating the turbulence. B. Rise from the surface to traffic pattern altitude. C. Accumulate and remain for a period of time at the point where the takeoff roll began. The correct answer is A. Wingtip vortices created by large aircraft tend to sink below the aircraft generating the turbulence. When an aircraft generates lift, the air flows over the wings and creates swirling vortices at the wingtips. These vortices have a rotational motion and, due to their higher pressure on the underside, tend to sink downward. And the aircraft continues to move forward, the vortices sink below the aircraft's flight path. This sinking motion is a natural characteristic of wingtip vortices. It is important for pilots of following aircraft to be aware of this behavior to maintain safe separation and avoid encountering the hazardous turbulence created by the vortices. 9122. How does the wake-turbulence vortex circulate around each wingtip? A. Inward, upward, and around the wingtip. B. Counterclockwise when viewed from behind the aircraft. C. Outward, upward, and around the wingtip. The correct answer is C. When viewed from either in front of or behind the aircraft, the vortex circulation is outward, upward, and around the wingtips. 9123. Which statement is true concerning the wake turbulence produced by a large transport aircraft? A. Vortices can be avoided by flying 300 feet below and behind the flight path of the generating aircraft. B. The vortex characteristics of any given aircraft may be altered by extending the flaps or changing the speed. C. Wake turbulence behind a propeller-driven aircraft is negligible because jet engine thrust is a necessary factor in the formation of vortices. The correct answer is B. The characteristics of wake turbulence, including its intensity and behavior, can be influenced by various factors such as the configuration and speed of the generating aircraft. Extending the flaps or changing the speed of the aircraft can have an impact on the size, strength, and persistence of the wake turbulence vortices. By extending the flaps, the wing's surface area increases, potentially increasing the lift and altering the formation and behavior of the vortices. Similarly, changing the speed affects the generation of lift and airflow over the wings, thereby influencing the wake turbulence characteristics. It is important for pilots to be aware of these factors and adjust their operations to account for the potential effects of wake turbulence from preceding aircraft to ensure safe separation.